Solving equations with variables on both sides of the equation. First, collect variables to one side of the equation. I recommend you collect them to the side with the greater variable coefficient. Why? Well, because then it will most likely stay positive, and positives are often easier to deal with. We all forget our negatives every now and then. So we're just going to practice some examples. You have a variable on both sides of the equation, so your goal is to get the variables all to one side of the equation, and then you're going to continue with our 3 simple steps to solve all equations. All right, I'm going to start with building a fence like usual. I'm going to look at this. I have 6x plus 22 equals negative 3x plus 31. So do I have more variables on the left or the right? More on the left, so I'm going to collect them all over to that side. So I have negative 3x variables here. And so I want to get rid of those and bring them all over here. I can't just move them over and say, now I have 3x. No, I need to do the same thing to both sides of the equation to keep it balanced. So if I have a negative 3x, the inverse of negative 3x would be plus 3x. So I'm going to do plus 3x to both sides of the equation. When I do that, this ends up being 0. I am left with a positive 31. And on the left side, I have 6x plus 3x, which equals 9x. And I also have a 22. Still want to get the variable by itself, so we get rid of that 22. That second term, subtract 22 on both sides of the equation. I am left with 9x equals 31 minus 22 is 9. And my last step is to get x by itself. Divide by 9, divide by 9. And I get that x equals 1. I could do a quick mental check. 6 times 1 is 6 plus 22. The question is that the same as negative 3 times 1, which is negative 3 plus 31? Well, what's 6 and 22? 28. What's negative 3 plus 31? Oh, I actually take 31 and I subtract 3, and I also get 28. So that does, in fact, check. I got the same thing on both sides when I plug in x is equal to 1. All right, number 2. Same first step, build a fence. Now, because there's actually 2 terms on this side and only 1 term on this side, no matter what, I actually would rather collect it to this side because it would make less steps. But the benefit is this is also the side with more w's. Why? Because this is actually a negative 12w and this is a positive 6w. So how do I get rid of that negative 12w? The inverse is plus 12w. So I'm going to add 12w to both sides of the equation. When I do this, that makes 0. I am left with 64 equals 6w and 12w is 18 w's. I then want to get the w by itself, so I'm going to divide by 18. 64 over 18 would be an answer, but I would like to simplify that. I'm not sure if it works out evenly, so I'm going to start by simplifying maybe with a 2. And 2 goes into 18 9 times, and 2 goes into 64 32 times. So I have 32 over 9. Can I think of anything else that goes into both 32 and 9? No, the only factors of 9 are 1, 3, and 9, and that's not going to help us. So my answer is 32 over 9 equals w.
I would like to give you guys, though, a chance to try number 3. 17 minus 2x equals 14 plus 4x, and you try. So that means pause and give it a whirl. Don't forget to get all the x's on one side. See you in a minute. Alright, welcome back. Hopefully you have built your fence and started collecting. I have negative 2x here and 4x here. I have more x's on the right side, so I want to bring this one over there. So the inverse of minus 2x is plus 2x. So I'm going to add 2x to both sides of the equation. When I do so, that makes 0. I'm left with just a 17 equals 14. 4x and 2x is 6x. I want to get that 6x by itself, so I need to get rid of 14. So I'm going to subtract 14. When I do so, I end up with 3. This is 0, and I get 6x. So is the answer 2? No! When I divide by 6, what is 3 over 6? That is actually a half. So I get that x equals 1/2. Did you get it right? Awesome. Quick check. What's 2 times a half? What's half of 2? 1. 17 minus 1 is 16. Let's see if this side also gets 16. What's half of 4? 2. What's 2 plus 14? Also 16. So I could do a check even mentally to make sure I am correct.
Great. Number 4. Build my fence Uh-oh, my variable's stuck in there a little bit. So what do I want to do first? Distribute! So I have n plus 14 equals 8n plus 56. Do I have more n's here or more n's here? I have 8 here, so I want to get rid of this n. Subtract the n, subtract the n. That makes 0. I'm left with 14 equals, what's 8n minus an n? 7n plus 56. I want to get the n's by itself. I need to get rid of that term. So I'm going to subtract 56, subtract 56. When I do so, I'm left with 7n equals, because this makes a 0, and 14 minus 56 is 42, positive or negative? Negative. So divide by 7, and I get that n equals a negative 6. I can plug it in. Negative 6 plus 14. Negative 6 plus 14 is 8. And if I plug it in over here, 8 times, what's negative 6 plus 7? That's 1. What's 8 times 1? It equals 8. So it checks. Yeah. Number 5, build my fence. All right, I need to distribute 1/10. What's 1/10 times 100, and what's 1/10 times 10 over 10d? 1/10 of 100 is 10. If you don't believe me, you can multiply it next to each and see, and 1/10 of 10 is 1d. And I keep a negative 34 minus 5d. All right, ooh, do I have more d's over here or more d's over here? I have negative 1d and negative 5d. In reality, it doesn't matter if I put my d's on the left or the right, but it's nice to work with positives. So actually, negative 5 is smaller because it's further into the zeros, further into the negatives, excuse me. So I'm going to do the opposite of negative 5d, which is plus 5d, plus 5d. When I do so, that makes 0, and I'm left with negative 34 on the right side. And on the left side, I have 4d, positive, and a 10. Let's get rid of the 10. Subtract 10, and I'm left with 4d equals negative 44. Divide by 4, and I get d equals negative 11. Number 6, you try. So give yourself a second. Push pause.
Distribute that 9. So I still have 6x minus 6 on the left, but uh-oh. Mrs. Nakama made a mistake. She used 2 different variables. Let's just call this an x. Hopefully you noticed that too. So let's distribute. You get 9 times x minus 9 times 4, which is 36. All right, I have 6x and 9x. I have more x's on the right, so let's get rid of this one. Subtract 6x, subtract 6x. This will leave me with a negative 6 on the left. 3 x's minus a 36. Let's add 36. Add 36. Negative 6 and 36 is 30 equals 3x. Divide by 3, and we should get that x equals 10. Remember to do a check. 10 minus 4 is 6. 6 times 9 is 54. So we're hoping we get 54 over here. 6 times 10 is 60. Minus 6 is also 54.